Okay, goed. Kom ons kyk gou na daai skets. Ek gaan nou saam met julle deur die voorbeelde in die boek ook gaan, maar ek wil eers bietjie makliker begin. 'n Watermolekuule. Né? Do you guys agree that the relative atomic mass of oxygen is 16 gram per mole? Okay? En waterstof is 1 gram per mole. The total relative atomic mass of that molecule, hoekom noem ek dit 'n molekuule? Nie metale, né? Waterstof en suurstof is mos nie metale. So this is a molecule. The total mass or atomic mass or molar mass of that is 18. Hoe het ek dit gekry? Ek het gesê 16 plus 1 plus 1. Almal by. Okay. So now when we are going to look at mass contribution, what do you think contributes the highest amount of mass to a water molecule? Suurstof of waterstof? It's built up of oxygen and hydrogen. Nee? Which one of those two atoms contributes the most mass to the molecule? I'll ask you again. Daai molekuule, daai ding, is 18 gram per mol. As ek 'n hele mol van hulle het, 6,02 maal 10 tot die mag 23 van hulle, dan weeg dit 18 gram, né? So it's 18 grams per mole. Of that 18, that is made up of hydrogen and oxygen. Né? Julle stem saam, in 'n watermolekuule is daar mos waterstowwe en suurstowwe. Which one of those two contributes the most mass? Hoekom suurstof? So even though you have more hydrogens, jy het 2 waterstowwe, né? Hoeveel weeg hulle in totaal? Maar 2, né? Well, if you look at the oxygen, how much does that weigh? 16. We're not going to worry about the units now. Maar julle verstaan, dis 2 eenhede teenoor 16 eenhede. So what we're doing when we're working with percentage composition, we say, let's calculate the percentage that oxygen makes up. It's going to be 16 divided by 18 times 100. Kom ons praat gou-gou oor daai twee dele. Waar kry ek die 16? That's the molar mass of oxygen. Where do I get the 18? That's the total mass of the whole molecule. So dan gaan ek sê 16 gedeel deur 18 maal met 100. Sê vir my, van daai ding se samestelling is 88,89% van hom is water. Okay? When I'm looking at the percentage hydrogen, I'm going to say it's 2 divided by 18 times 100. Hoekom sê ek 2? Because I have 1 and then 1 more. Nee? In totaal dra hulle 2 massa eenhede by. The one contributes 1 and the other one contributes another one. En daai twee saam moet ons weer by 100% uitkom. Daar's mos niks anders in daai molekuule nie. Okay, so let's look at the ones in your book. It says determine the percentage composition by mass of that whole thing. Okay. Waar ons gaan begin is ons gaan sê, kom ons werk eers uit, wat is die totale moleire massa? So I'm going to say sodium contributes 23, hydrogen contributes 1, carbon contributes 12, and then I have 3 oxygens, each contributing 16. So daai ene kom van daar af. Daai een kom van daar af. Daai kom van daar af. En almal van daai kom van daai af. Almal by. Meaning that the relative mass will be 84 grams per mol. Nou wil ons gaan uitwerk van daai 84 gram per mol. Hoeveel dra elkeen van daai 4 verskillende soorte atome by? You guys see it's made up of 4 different ones. Né? So, ek gaan sê, as ek sê die persentasie natrium, I'm going to say it's 23 divided by 84 times 100. Waar kry ek die 23? Dit is die molêre massa van natrium. Waar kry ek die 48? Nee, 84. That's the total mass of the whole compound. Okay. Dan gaan ek sê die persentasie waterstof is 1 gedeel deur 84 maal met 100. 1,19. Okay. Wanneer jy gaan kyk na suurstof, kyk mooi. Jy gaan nie net sê 16 gedeel deur 84 nie. Because we don't only have one oxygen. We have 3 oxygens contributing to each of those. So jy gaan sê 3 maal 16 gedeel deur dit. Soos daai. Maklik? Is nie moeilik nie. Okay, then the one next to that, they just do the same for iron oxide, but I'm not going to go through that one as well. Ek gaan vir julle 'n paar van hulle gee nou om te oefen. But it's not difficult. Jy werk net die persentasie samestelling uit. Okay. Now from that, we are going to move to empirical formula. And you guys need to know the definition of empirical formula. Hallo. Ek kan gou vir jou vra. Ek vermoed sy is dalk in die personeelkamer. Okay, ek sal vir haar sê jy soek haar. Okay. Okay, goed. Okay, goed. Kom ons kyk na 2 verskillende molekules. Okay. Water en waterstofperoksied. Water and water peroxide. No, it's just peroxide. Hydrogen peroxide. Okay. Goed. Albei van daai word saamgestel uit waterstowwe en suurstowwe. Do you guys agree? The relationship of hydrogens to oxygens in this one is 2 to 1. Do you agree? Vir elke 1 suurstof is daar 2 waterstowwe. Yes? But when we go look at this one, the simplest ratio representing the amount of hydrogens to oxygens is 1 to 1. Sien julle, vir elke 1 suurstof is daar 1 waterstof ook. It doesn't mean that you only have 1 oxygen and 1 hydrogen. But for each 1 oxygen, you have 1 hydrogen. Stem julle saam? So when we're talking about the empirical formula of water remains this. Want daar's mos nie 'n eenvoudiger manier om te skryf nie, né? That's the empirical formula of water. But the empirical formula of hydrogen peroxide actually looks like this. Is daai die formule van waterstofperoksied? No. But you guys see that that is the simplest form in which we can write it. Meaning that for each one hydrogen, we have one oxygen. Dit is nie sy chemiese formule nie, dit is sy empiriese formule. Ons gebruik dit veral wanneer ons kom by organiese molekules. So, an example of that is when you are working with long keten, wat die mense goeders, soos petrol, pentaan en daai goeders, okay? Then it means that it looks like this. Okay. Daai is 'n octaan molecule. You guys don't need to know that yet, okay? That is the chemical formula of that molecule. Stem julle saam? Nee, julle kan gaan tel. Hy het 8 koolstowwe, 18 waterstowwe. What would the empirical formula of that be? Do you guys agree? Because for each 4 carbons, we have 9 hydrogens. Hy split hom eintlik hier mooi in die middel. Sien julle 4 koolstowwe, 9 waterstowwe, 4 koolstowwe, 9 waterstowwe. But it doesn't mean that you only have 4 carbons and 9 hydrogens. It just means that the simplest relationship of the atoms in that molecule is 4 to 9. Okay. Nou, julle gaan nou leer hoe om self die empiriese formule uit te werk. And we're going to start there and we're going to work towards molecular formula. But I first want to start with just the empirical formula. So when I'm doing that, ek kyk na die ene op bladsy 281. They say mercury forms a compound with chlorine that contains, so we've got mercury and chlorine. Okay, hulle verbind met mekaar en binne in daai verbinding is 73,9% die kook en 26,1% is die chloor. Okay, so we've got the mercury and we've got the chlorine. They bonded together. We don't know how. 2 tot 1, 1 tot 2, 5 tot 9. We don't know. We just know that in that compound, 73,9% is mercury and the other 26,1% is chlorine. Dit kan 1 wees teen 2 of wat ook al. Ons weet nie. Okay, almal by. Now what you do is you say, let's say I had 100 grams of this. So jy maak nou asof jy 100 gram daarvan het. Okay. Van daai 100 gram, hoeveel gram sou kook gewees het? Stem julle saam? Nee? As ek sê nou maar 'n monster gehad het met 100 gram van hierdie onbekende stof, dan sou 73,9 gram daarvan uit kook bestaan het. So if I had a sample of this unknown compound, then of that 100 grams, 73,9 grams of that would have been made up of mercury. Nee,